Hello, everybody. So my name's Alex Skene. I'm a technical partnership manager and actually product manager for Etherlink. So we're here to talk about how Etherlink is now super fast for latency in a bit more detail. So do you guys want to introduce yourselves?
Hey, I'm Dmitry, founder of Hanji. So we have been building in Tezos ecosystem for quite some time. And Hanji is fully on-chain spot club DEX, live on Etherlink and some other EVM chains. And yeah, excited to be here.
And hi, I'm Sylvain, software engineer at Nomadic Labs. I've been there for the last couple of years, and particularly working on the layer 2 space from smart rollup to Etherlink now.
Cool, thanks. So, I mean, can you give me like a 30-second sort of quick thing? What is an instant confirmation? What does it actually mean?
So sure. So user interaction with EVM chain is you submit a transaction, wait for a block to pick it up, and then get the receipt of that transaction. In Etherlink, that workflow is less than a second, about 500 milliseconds. And with Etherlink, with instant confirmation, we were able to reduce that to 50 milliseconds. This feature is already live on Etherlink since January. And currently, for any users to get that kind of latency, they just need to run a node, enable the feature, run a node close to the sequencer. This is important for the latency, network latency, and enable that feature and use the available API.
Cool. I mean, you and I, we talked at this time last year. We talked about instant confirmations a bit. You know, can you remember the conversation, the sort of things, why it was important to you, and what it meant for Hanji?
Yeah, I think I was pitching this thing last year. Basically, it's super important for on-chain trading and for market making. Basically, the faster the chain is, the faster you know that your transaction landed. Means that the faster you know it, the less risk is for you. Because for example, if you quote some asset pair and there is like 1 second or 500 milliseconds where you don't know if your transaction succeeded or not, then you need to factor this into the spreads you quote because there is significant uncertainty. Basically, market can move in any direction in these 500 milliseconds. And so you need to quote wider. And as soon as we are able to make this distance in time as small as possible, so about 50 milliseconds currently, then we ultimately allow our market makers to quote tighter, and so we get better liquidity and better spreads for the users.
Cool. And it's something you spotted straight away, that an opportunity, right? That we can make use of this.
Yeah, I think because back then most focus probably was on throughput, but actually throughput is, I think, to a high degree kind of solved, because if you look at throughput numbers that chains advertise and the actual throughputs that we see in like block explorers, we usually have like 10 to 100x more throughput available that is actually used. While latency is actually critical because latency affects trading every day and affects the liquidity of the assets.
Cool, yeah. And you know, instant confirmations is something we built because we asked for from users, and I guess it's just part of a wider system of a lot of changes which have been going on, improvements in Etherlink and on the EVM side as a whole.
Yeah, so what is nice actually with instant confirmation, it's as it's not directly linked to the runtime that is used, it's a feature built mostly on the node part and interaction between nodes. It's going well with the Tezos project and in that roadmap, and we just a neat work to done from making it available as day one on Tezos, and it's going to be available on day one of Tezos.
Cool. And I mean, instant confirmations is not, I guess, a very new. Quite a few other chains have been talking about reducing latency as well. I think flash blocks was from Base was one of them.
Yeah. So flash blocks, Base flash block and Etherlink instant confirmation has the same goal but a different approach. So Base worked at the level of a block by submitting slice of the block every 200 milliseconds to be consolidated into a block every 2 seconds. Whereas with Etherlink, we work at the level of the transaction by making the sequencer commit to any transaction it's going to include in the next block, broadcast that, and so any node that follows the sequencer can execute the transaction that is going to be included. So we measure 50 milliseconds for execution on the local node for a block that is going to be created in the next 500 milliseconds.
Cool. And first come first, it's first come first served as well compared to like
yeah.
I think it's gas auctions on Base, right?
So one of the big difference with Base is the way transactions are ordered. Where, for example, for Base, they order transaction per gas consumption and with a priority fee. So small transaction with high priority is going to be included first into the block. Mm-hmm. Where in Etherlink, we had fair in mind and we chose first come, first serve process. So the sequencer is going to include any transaction in the orders it receives.
So, I mean, does Hanji take, is first come, first served as important, or is it this raw speed, which is, to you, the most important one? Or?
I mean, reduced latency is most important, I think. Yeah. But yeah, first come, first served is also interesting. I just wonder if you can go around it if you send a lot of transactions. So sort of, you get similar effect to priority fees.
Well, I'm sure we'll find out, right?
Yeah.
I mean, it was quite, I remember during the engineering, it was it technically quite hard to do? Were there any speed bumps along the way? What was the hardest thing you found to do?
Yeah, maybe the hardest thing, I think it's, so Etherlink is one sequencer, multiple followers, and is to make sure to have no divergence between the way the sequencer executes the block and the way the followers execute them. So with instant confirmation, the sequencer is still executing the transaction as a block at once, whereas followers are going to receive transaction one by one, so execute them incrementally. This part was actually hard to get to make sure there was no divergence between the view of the observer and the view of the sequencer.
Cool. Yeah, that sounds tricky, right? Yeah, we made it in the end, right? And I think it's been quite successful. We've seen, we did a demo and it was taking like 20 milliseconds. If you're this close to the sequencer in Tokyo, it's quite fast, right?
Yeah, it's really fast now to execute your transaction, to have the receipt of your transaction.
Cool. So what does it mean for Hanji users now that 50 milliseconds is there ready for you? Does it change the needle anymore? Does it make?
So we're currently working on incorporating these changes into our stack. So we are investing effort in making our APIs more reliable, and eventually it should affect our market maker partners so that they can quote faster and more reliable on our DEX. So
does it mean better prices or?
Yeah. At the end of the day, it means better prices. So that's the only way users can see it actually. Another small stuff for users is that for 500 millisecond block, all events happen in batches for 500 milliseconds, and it may look less less continuous, so to speak. Even though user front end usually has additional delay, so it's less critical to be 50 milliseconds fast. Still, it can affect UX, I think.
Yeah, cool. What else can we do with them? What we know from what other use cases are there that we have in mind for instant confirmations?
So, for a user to wait a couple of seconds to make a payment, it's not an issue. But for NG, it's important. Yeah. And I would say another use case would be in gaming, where you have a lot of inputs coming at once and where you have to react really fast to any of those inputs. Having any latency is going to break the player workflow and going to be annoying and make the game not really nice.
Yeah, I guess you can imagine, like with this AI, now you can have interactions on chain on Etherlink and get responses back.
Yeah,
much quicker,
for sure.
right? So it's going to. I think it unlocks a huge amount of other things. And do you think you could do anything else with it? Are there any new DeFi primitives we could use using the reduced latency?
I think it's mainly about trading and quoting quality. So it's probably less like different features, but more than working deeply into one direction, I guess.
Okay.
Yeah, and it's important that right now Etherlink is one of the fastest chains out there to trade and to build trading-related products.
That sounds good. So, you know, from I guess what comes next for the feature? You know, how do we? This is probably a question for me, right? Because I'm the product manager. But from the implementation side, what's left to do on the feature?
First is to enable it by default for all nodes to have that feature. So public endpoint will have it available and everything like this. And then extend the API available that can use that the incremental state actually. So any Ethereum RPCs that we support that can have that have an interest of having the incremental state will have the possibility to query it. And we are another part we want to work on is we currently have benchmark 95% of the transaction under 50 millisecond, and we just want to get it to 99. So have a nice number with that target.
That's cool. And you've mentioned implementing it, the main features to get it for end users. So what's next for Hanji other than that? Oh.
I think an important part is once you have this good latency, you can actually build more complex products. For spot trading, it's probably it's good to have as low latency as possible, but still you can live. With slower latency. I mean, we saw that slower chains also have spot trading, but like for leverage trading and for perp trading, that's low latency is especially critical because you need to be able to handle much higher volumes, and you also need to be able to handle liquidations on time. So that's really important, and we're also looking into this direction later this year.
Cool, thanks. And if you want to start using the feature now, what do you have to do? Other than go read the documentation, and what's the easiest way to get started?
The documentation is an important part, but there is just a flag to add into the configuration of running node, and with that, with a node that you run, and with that you can use either currently draft Ethereum RPC called Sendro Transaction Sync that will give you the transaction of the receipt of the transaction you just submit, or use any. We have implemented 2 WebSocket stream, and you can use any of the 2 to get the feature, instant confirmation feature.
Cool. If you have, I think, is there anything else you want to add? Any last minutes? Any thoughts?
I just say that it's really convenient. We can just send raw transaction sync and get a response immediately. You don't have to poll every time and wonder what happened with your transaction. So yeah, it's just also better UX, I think.
Cool. All right. Thanks very much. Do we have any
Amazing.
questions?
Do we have questions from the audience? Yes, one here.
Hi, I have a question regarding the competition with centralized exchanges. For now, they still capture a vast majority of the volumes compared to DEXs. How much do you think this instant confirmation allows you to attract those volumes from centralized exchanges?
So I think it really helps with UX challenges. So previously, like speed was a high blocker, I'd say. So now I think with fast confirmations, speed is actually on par with centralized exchanges. I mean, it's not on par, technically, but we see that some other perp dexes which have similar latency, like Hyperliquid, for example. So I think they have 200 millisecond block or something like this. They are able to compete with the Texas, and so I think speed is no longer blocker for Etherlink dexes.
Nice. I actually do have a question. How fast or how low do you think we can actually go?
So just to explain a bit, maybe the benchmark, we run the benchmark in a VM with a node close to the sequencer. And on that benchmark, we were able to monitor ERC20 transfers, so classic transaction. And about 80% of them was 20 to 30 milliseconds. So, and that time is mainly processes, so there is almost no network latency. And we'll see if we can go lower than that, but it's actually already impressive, I think.
Thank you so much, guys. Thank you.